Hello all, today in this video we are going to make a demo with SVM linear with regularization. Previously with regularization we have worked with 1.0 and we got no change. In this code we are going to work with 10.0 regularization. In that we are getting some changes. We are making some comparison also with another kernel functions like sigmoid, RBF and polynomial, and also from that we got the better thing as linear kernel in this particular data set. So for that, for linear kernel we are getting with the regularization parameter. Then we are initially importing the library which we are needed and the data set. The data set we downloaded from Kaggle. We just got as a heart disease detection Kaggle dataset. Means you will just get this dataset. This dataset is having nearly 14 rows. Among that, the first 13 rows we will be using for the x variable, and the last variable, that is the target one, we will be using for the y variable. Then we are getting the info of the dataset, whether what is the type of the thing. Then we are getting whether the data set is having any null values. If it is having any null values, means we have to work with pre-processing functions. Since our data set is not having any null values, we have neglected the pre-processing functions, and then we are getting the shape of the data set, and we are making a plot by using the target variable. With the target variable is having two counts like 0 and 1. With that we are making a plot like which count is higher. So both are less is more or less same, but when compared to 1 0 1 is having some higher counts. Then we are using the train test split function and the use of the x variable and y variable with the test size of 0.2, that is 20% for testing and remaining 80% for training. We are determining variables like x train, x test, y train and y test, and by using this variable we are making the SVM uh, classifier with the different kernels. First we have worked with the linear kernel. For that, within the SVM function we are kerning the kernel as linear. Then we are fitting using the fitting function to train the model and the training variables, and then we are using the predict function to test the model and the testing variables, and then we are determining a prediction variable. By using this prediction variable and the test function, we are displaying the confusion matrix, and then we are displaying the classification report parameters like precision, recall, F1 score and support, and we have got an accuracy of 80% for this data set. Every time we are working, this accuracy will change. Then we have worked with the sigmoid kernel, and then use the fit function for training and predict function for testing, and then we have displayed the confusion matrix, and then also printed the classification report and have got an accuracy of 58%. Then we have worked with the radial basis function kernel, and then we have trained the model by using the fit function and tested the model by using the predict function, and then displayed the confusion matrix and also printed the classification report and got an accuracy of 61%. Then we worked with the polynomial SVM kernel and then trained the model by using the fit function and tested the model by using the predict function, and by using this predict variable and the test function we are displaying the confusion matrix and printing the classification report and have got an accuracy of 64%. From this we have got an conclusion that when compared to other kernels, this linear kernel is providing better results. So with this linear kernel we are using some regularization parameter, and first we have worked with this as c is equal to 10, and then we are trained the model by using the fit function and tested the model by using the predict function, and then displayed the confusion matrix matrix, and also we have got the classification report and got that accuracy same as the linear kernel without any change. So we are giving some different regularization value as 10.0. In that case, we are getting, we have plotted the confusion matrix and also displayed the confusion classification report. Here we have some changes which is decreased. Previously it was 80, now it is 79. Then we are making a comparison of all the models, that is all the kernels and the is linear kernel SVM with C is equal to 1.0 and 10.0. All these models we are making within an variable called model, and then we are determining a loop. Within the loop we are training this model, testing, and then also determining variables like accuracy, mean square error, R2 square, etc. And then we are printing the training accuracy and also the testing accuracy of every model. So the training accuracy and testing accuracy of every model is found within the single cell. Also we are making a table comparison with by which within this table you can notice green color and red color. That is, the model with the best accuracy will be shown with green color and the model with the least accuracy will be shown with the red color. Since linear SPM without any regularization parameter and with regularization parameter as 1.0, we are getting the same value. Both are showing red color, but when coming to 10.0, some accuracy change is there, which is 78. Then after this linear SPM, polynomial SPM is providing better result. After that comes the radial basis function, and finally sigmoid SPM. The next video we can work with some other regularization parameters and we can check whether it is increasing or decreasing. Thank you.